Morning, everyone. So for those who don't know me, my name is Kevin O'Brien. I am a pediatric hospitalist and our first and current clinical informatics fellow finishing up this year. And I have the pleasure of introducing Dr. Michael Padula. I'm going to take a slight tangent for a second to jump back to the last presentation. For those who remember the toilet picture and Dr. Eric Shevlov's presentation or sharing with us remotely, he and I actually attended a course together this summer, and I really got to know sort of everything that CHOP does and how they structure their work, how they really run their informatics program. And so as we head towards the panel, think about sort of how you might want to understand what they want to do or what they do on a daily basis and how we can translate that here. So Dr. Padula got his medical degree from Princeton University and then did his residency at Thomas Jefferson University and followed by a neonatology fellowship at CHOP, where he's remained as an attending neonatologist since then. He also has a certificate degree in epidemiology and biostatistics and then a master's degree from Oregon Health Sciences in biomedical informatics, which is the program that I'm currently in as well. And so I have a experience of what he's been through with that. He has numerous publications in most of the field of neonatology, focused on things like length of stay and interventions to improve outcomes. And he's a founding member and executive committee member of the Children's Neonatal Consortium. And Dr. Padula will be talking to us this morning about data standards and terminology as it applies for sharing data.
All right, good morning, and thanks, Kevin and Pele and everyone here for being such fine hosts. Apologies in advance. I seem to be losing my voice just in time for this talk, but I'll do my best to bear with you. I'll just move through a few things quickly. I'm trying to cover a lot of ground. So I'm talking about some health data standards in general, particularly clinical terminologies, and sort of why they're coming into greater use in current state, and other ways we can potentially leverage them. I have no disclosures or conflicts of interest. The objectives include, but are not limited to, reviewing examples of commonly exchanged clinical information, talk a little bit about the relationship between interface and reference terminologies, and touch on some of the standards cited in meaningful use, and that's part of the push towards standards now. So we'll start with a pretty basic use case. A 47-year-old female with type 2 diabetes presents to the emergency department with right upper quadrant pain. She's seen in the ED by a clinician there. They order some labs and do an ultrasound. They make the diagnosis of gallstones, and when they enter that in their EHR, it's mapped to a reference terminology in SNOMED CT, known as choledocholithiasis. She's then discharged for follow-up with a primary physician and perhaps a surgeon. So at the time of being discharged from the emergency department, in conjunction with standards for requirements for meaningful use, they send a continuity of care document, a CCD, via direct message through their health information service provider to her primary physician. And this CCD includes problem list, allergies, medications, procedures, lab results, and some other follow-up plans. It's really geared towards transitions of care. Although it's in an XML form, when it gets to her primary physician, that XML is rendered in a style sheet that makes it easier to view and review. And so with that framework, I'm going to back up and cover a little bit about standards in general. So we sort of take standards for granted, I feel. There's a lot in the engineering domain, but others as well. And quite simply, it's just a reference. It's a document established by consensus, approved by a recognized body, usually a standards development organization, that provides for a common and repeated use, rules, guidelines, and characteristics for activities aimed at achievement of an optimum degree of a given content. So over time, you see examples of where standards have solved solutions that we now see. When people used to travel from the north to the south in the 1800s, they used to have to reconfigure trains when they went from one region to another. And then in 1963, after some arguing, they agreed, hey, we'll just move our rails 3 inches inward, and we can solve this problem so they can go continuously. It's like a simple problem, but you have to come to agreement. Similarly, in the early 1900s, there were a lot of different manufacturers with different light sockets, and then coming to a common ground helped that. And we also take for granted that we can go to an ATM anywhere in the world and get whatever currency, and it can draw from our bank, and it's seamless. But in order to do that, it required compliance with standards. So what does it take for us to adopt standards in the healthcare domain? And ironically, it was a recession. So back in 2009, after the stock market crash, there was the Congress met and passed what was known as the American Recovery and Reinvestment Act. And in that act designed for economic stimulus, there included a small highlighted blue line on page 127 of this 400-plus page document that referred to the HITECH Act, the Health Information Technology Act. And within that includes language for what we refer to commonly as meaningful use of an electronic health record system. Right there. So, this is a high-level overview of the different stages of meaningful use. Stage 1 was primarily promoted towards just everyone adopting an electronic health record. Stage 2 raised the bar a little bit, pushing towards some standards for health information exchange as well as patient engagement, being able to get their own records. We very recently released Stage 3, which includes more of the same goals, although they want a higher percentage of records where you've sent and received summaries. And they also are requiring a high percentage of times where you reconcile medications, problems, allergies at your transitions of care. In addition to that, they also use some of the same standards for reporting to various registries, such as the cancer registry, but you can report healthcare-associated infections and all sorts of things using some of these standards. And so, sorry this didn't come up super clearly, but within meaningful use, they highlighted a few specifications for the continuity of care document, what is now consolidated CDA, as well as reference terminologies for clinical terms and drugs and lab results that I'm going to just give a brief overview for today. Now, I apologize. I'm going to start at a pretty basic level and just build from there. But just these are sort of underlying fundamentals of some concepts. So a concept itself just represents a unique idea, and it's independent of language. So when I refer to my hand, or it's a mono, or you could have another name for it, it's the same thing to everybody. Now, these concepts are typically uniquely identified by a code. So the code for a concept of a heart attack or myocardial infarction has a code in SNOMED CT that it correlates with. For any concept, you can have a term, a string that refers to that concept. And then you can have more than one term referring to the same concept, which is a synonym. Now, often, some of these conditions can have a preferred term. So the disorder of Wilson's disease, which may also be referred to as hepatolenticular degeneration syndrome. But regardless of how people know it, it's still going back to the same concept. So concepts represent unique ideas. Codes uniquely identify those concepts. We use terms to refer to concepts as humans, but computers communicate concepts using codes. And while concepts are language independent, regardless of your language of origin, terms are different according to where you practice and what your domain is. So terminology at its most basic most basic point is a set of concepts designated by terms that belong to a specific domain of knowledge. So then when we stop and say, what is a reference terminology? A terminology in which every concept has a formal machine-usable definition or code supporting data aggregation and retrieval. And they're designed to provide a complete and exact representation of a domain's knowledge, including entities and ideas. And the real key is the relationships, which we'll touch on a little bit. But if you can capture that with some of these ontologies, it becomes really valuable. And is really optimized to support storage, retrieval, and even classification of data. Now, classification is a little different from terminology, and is really meant to group things together, not to provide a granular difference. Over time, that's evolved a little bit, going from ICD 9 to 10. But when you look back at its origins, it was originally designed for classifying data. So they wanted to say, all right, what categories can we put these things so we can follow things from a public health standpoint? So everyone's familiar with ICD-9. But it's important to remember the limitations that it was only meant as a general, primarily billing-related code, and that it often lacked the granularity we need to deal with many of our clinical concepts. Now, ICD-10 is a new animal that has many more types of concepts, if you will, for classification. And although it seems unlikely they may be struck by a turtle or be injured due to a burn with flaming water skis, sometimes things do come up where people are actually injured in an opera house. But that is not I'm not here to talk about these classification systems. What I really like to bring up is a concept of an interface terminology. And so what an interface terminology is sort of a maintained set of terms that are meant to be compatible with the natural language of the user. So these are terms that clinicians would use when they refer to their problems. And if you consider how we can move towards capturing data, getting secondary use of data in a meaningful way, it's really helpful to use terms that are useful to the clinicians. So, for example, if you use the term heart attack, you know that means a myocardial infarction. If you're referring to an infant that's premature, it actually maps to an awkward term known as prematurity of the fetus, which in SNOMED, it's a bit of an oxymoron, obviously, but no clinician would rightly pick that from a list, or would be frustrated by having to pick that from a list. But if they can do it from an interface terminology, there's some potential benefit there. So the other thing I wanted to touch on is the relationships between concepts. And this, when we start to look at aggregating data or trying to figure out how we can group more granular data, it becomes really valuable to look at different concepts where you say a myocardial infarction is a type of disease, and it's a disorder of heart muscle, and it's also a type of heart disease as well as a myocardial finding, and this sort of hierarchy, if you will, provides a lot of latitude for relationships. Again, I apologize, a lot of these things are kind of basic, but I'm just going through bit by bit. So an expression refers to, references one or more concepts to represent an instance or express a clinical idea. If you have just one, if you're able to represent the idea with a single concept or code, we call that a pre-coordinated expression. If it takes two or more concept identifiers, we call it a post-coordinated expression. What do we mean by that? Well, if you're dealing with blood pressure, we know that they have different techniques of doing a blood pressure. You may be sitting, standing, or supine. You may have different ways you measure it. But if you're saying, look, for my purposes, I want a sitting systolic blood pressure, there's a pre-coordinated concept for that. Or you could say, I want to represent a systolic blood pressure in the sitting position, and that required two different codes. So there's a flexibility here, but it's also important when you aggregate data to be aware of the potential options. And it's also very important from a data modeling standpoint, because if you are doing a study and you know you just needed a coordinated concept of a sitting systolic blood pressure, then you just need one field. If you need to be able to accommodate every type of blood pressure that's offered, well, then you also have to deal with what technique was used, what extremity was used, was it the left or right? So, it can become more complicated. It all depends on your need. So then, very importantly, the concept of what we refer to as an ontology, and that's sort of this hierarchical structure of concepts and the relationship of those concepts. So you can have the concept acute myocardial infarction. Its parent concept is a myocardial infarction. This is less specific in a more broad term. And then you can also have a subtype or a child concept, such as an acute anteroseptal myocardial infarction. So this is more specific and granular. But because you capture this within this ontology, you have an opportunity to benefit from looking at the different relationships. And then just to complement ontology, there's also a nomenclature, which is just a systematic way of naming things, where codes are often assigned to medical concepts, and they can combine according to specific rules. So in order to build these post-coordinated concepts that are more complex, you have certain rules to make sure people do it the same sort of way. And then quite simply, mapping is just the idea of mapping or developing relationships between concepts of two different terminologies that facilitate exchange of information with a common meaning. So the important thing is you're trying to say, when do we have a like concept? How is this represented in one terminology versus another? So, at your individual institution, you may have this code for diabetes, and that may map appropriately to the SNOMED code, diabetes mellitus, with that SNOMED ID. But if you're dealing with a large set of multiple clinical information systems, it becomes very complicated then to develop all these interfaces to come up with a similar semantic meaning among all of them. Hence the role of a reference terminology, where you can say, all right, we just want you to get your terms back to this standard reference terminology, and from there we can relate it to other data sets. And in the concept of an interface terminology, it also allows you to take the same clinically captured term, in this case I'm using bronchopulmonary dysplasia, you can even get a greater degree of granularity for a mild, moderate, and severe, and you can then map these to the appropriate coding classification or coding system, as well as a reference terminology. And to the user, they're just using the terms they normally would. So now they've covered overall some concepts in terminology. We have the idea of interoperability. And quite simply, that's the ability of two or more systems to exchange information and use the information that has been exchanged. There are other definitions that address the specifics of accuracy, effectiveness, and consistency, but it's the same basic concept. But now there are different types of interoperability. So we have interoperability to exchange from all these different places, from your pharmacy system to clinicians, the front-end application, health plans, etc. But when we sort of categorize interoperability in general, one common way to approach it is refer to technical interoperability, which really refers to the syntax, you get a lab with a certain unit. But what really I want to focus on is something known as semantic interoperability. So one of the values in using these terminologies is that if you use the same reference terminology, you're a step closer to making sure that your systems understand the data in the same way. And this really helps to enable computers to share and use data without ambiguity. And then there's a higher level concept, which we're still working towards in terms of process interoperability, where across an entire network, all these processes can be integrated into your workflow. So here I've come, pardon me, to SNOMED CT. So what is SNOMED? It began as the systematized nomenclature of pathology developed in the U.S. by the College of American Pathologists, and it expanded to other domains of medicine and had several iterations, and eventually became known as a reference terminology. And then in the early 2000s, they combined those, sort of harmonized these with a set of clinical terms from the UK known as read codes, and that's when it was transformed to become this SNOMED clinical terminology. The College of American Pathologists had transferred this to the IHT SDO, which is now in Denmark, and they manage it. So what does it do? It's it's referred to as the most comprehensive multilingual clinical healthcare terminology in the world. It contains terms attached to concepts with multiple terms per every code, and then has a logic-based representation of meaning. Well, what does that mean? It's really about that ontology and hierarchy that allow it to capture different relationships. So concepts representing clinical meanings are organized into hierarchies, and the descriptions in each domain, like in the U.S. realm, you have a set of terms that refer to that concept. And the relationships can also be established to link concepts to one another. So here we have a whole subset of SNOMED hierarchies that could have all different types of attributes and findings. And you show the relationship between those findings to, for example, you'll say an arthropathy is a type of joint finding, and an appendicitis is, because you have itis, it's a type of inflammation. And it provides this overall framework to facilitate its use. So we go back to our myocardial infarction example. It has a single code, and it has a preferred term, which in SNOMED is known as this fully specified name, and it has all these synonyms, which are also acceptable. And they say, even though there's a preferred use, you can still get to the same code using those descriptions. And in short, just like I mentioned, just this isn't rocket science, but A femur fracture is a type of fracture, and that relationship is captured with a certain code. And so you can deal with parent and child concepts in part of the hierarchy, and then you can also introduce or establish a relationship with other terms with establishing those relationships that we mentioned before. So a myocardial infarction has a lot of child concepts, and it also has different parent concepts. And when you have more than one parent, it's known as a polyhierarchy. So MI is a myocardial disease, and it's a type of ischemic heart disease. Similarly, Wilson's disease can be organized under other parents. So it could be a disorder primarily presenting with chorea. It could be a disorder of copper metabolism. We also mentioned that it can have findings in the brain or the liver. So the way, so why go through all that trouble? Well, part of the reason is how then can you leverage this hierarchy, this ontology, this framework that established all these relationships? And you could say, well, I'm looking for all the different benign neoplasms. And since that's one of the parent concepts, you could do a search looking for the SNOMED codes that all deal with benign neoplasm. Similarly, you could take all the concepts relating to the kidney and group those together as well. I won't go through this in great detail, but these are just general rules on how we can, it's as a nomenclature, the rules by which you state, hey, we have an appendectomy, and it has a priority that's an emergency, and you're using a cyst device that has a laparoscope, and then you can get a pretty specific concept to represent these, this clinical idea. And they have a particular way that these things can be represented. And SNOMED CTs is free on the web. They haven't always had this, but IHT SDO has a good browser. I encourage you to take a look. The other reference terminology, one of the other reference terminologies I'm going to touch on was LOINC. And those of you dealing with the lab domain are very likely familiar. It was originally developed in '94 by folks at the Regent Street Institute in Indiana. And as a nonprofit or an organization, they just wanted a database for standardly identifying medically laboratory observations. And it's great that it's available at no cost, and it's used internationally widely. And although these concepts, it was primarily best known for the laboratory domain, it is also used in the clinical domain for certain instances. So, say, for example, you wanted to check somebody's hemoglobin A1C, and then you looked up and said, whoa, there's a lot of different ways they can actually run this test. It becomes very important because you can see that there are different assays that they may use to get to that result. And there's an important disclaimer at the bottom. It says these protocols produce different results when expressed in the same units. And so that in using one result, a value of 6.5 is equivalent to using another value, getting the result of 4.8. Obviously people know about how PT values can vary, and therefore people use an INR, international normalized ratio. But all of a sudden you can say, well, sometimes if you're bringing large groups of data together, it's not maybe not just enough to have the value, it's important to know what test or assay was done. I won't cover this in too much detail, but there are certain fields that are followed in the LOINC format, including things like what specimen and various units and other data. Additionally, there are LOINC, clinical LOINC codes, which may indicate a document type. It may indicate a number of different clinical concepts. And in focusing the standardized terminology world, when they need to do it, it's often easier to get a concept added to LOINC quickly than it is to a reference terminology like SNOMED. And there are also ways you can browse these for free as well. The last one I was going to, a main one that is also cited by Meaningful Use that I wanted to touch on is RxNorm, and it's a normalized naming system for both generic and branded drugs, and it's really goal towards semantic interoperation between different drug terminologies and pharmacy systems, and it's produced by the National Library of Medicine. It covers both clinical drugs and drug packs, and it includes usually it covers a lot of the different ingredients within them too. It has mappings to all sorts of codes from clinical or proprietary products like First Data Bank, SNOMED, different Metaspan. All these Rx is able to provide a lot of these different mappings. And again, we're solving the same sort of problem where instead of having to develop different mappings or interfaces among all of them, you push everybody towards a common standard and get this sort of Rosetta Stone, if you will, to allow people to exchange information. And RxNorm isn't the only one per se that could do this, but it's the most common one cited. So I'm going to shift gears a little bit and talk about things that support clinical document architecture. So those folks who hear Health Level 7, it's something designed to help exchange of information among clinical information systems, and there's a whole set of standards that's been around since the mid-'80s. And in our hospital systems, in over 90% of the hospital systems in the U.S., they use HL7 in the form of version 2 messaging. And that's a different format where you have different hats and pipes and bars and different codes that are somewhat unique. But all of our ADT systems, admission, discharge, transfer systems, the way you get information from probably your lab information system to your EHR or what have you, often use version 2. The idea for version 3 meant to get a full set of message data types to provide a complete implementation. And it's a newer approach to, not as new as FHIR, but it's newer to create these messages using XML, which is extensible markup language syntax. So this is the reference information model, and this is the fairly complex model, really meant to deal with all the different actors in a healthcare system, all their workflows, things like substance administration, allergies, contraindications, etc. All these things are covered in this quite complex model. And then the content of these messages are in these XML tags. So extensible means you make as many of them as you want. It's not a constrained set. Markup means basically you're labeling everything in it. So this is obviously used well beyond healthcare, and I'm sure you've encountered in other domains, but the idea here was to use this format to label everything so it's both human readable as well as machine readable. It's not quite as efficient as JSON, which is used in FHIR that BMO alluded to earlier, but it's a starting point. So for clinical document architecture, also known as CDA. It's a document markup language standard trying to design for a clinical document. So I usually think of it as being this sort of complete bundle or set of information for a specific instance that you then have certain criteria for. It's built on a number of templates that can be computable potentially. And you can have these templates at the full document level, at a section level, or an entry level. And I'll show you that in a second. And it's meant to be expressible and flexible. And from that, we have different levels, which I'll touch in a moment. So at its core, version 3 use of CDA, Clinical Document Architecture, is different from what we normally see for version 2 of HL7. Very briefly, HL7 is a messaging standard. So you get a lab, you get acknowledged that the lab was received, you say the result is pending, you send the final result, and you'd have these transient messages. The idea of a clinical document is that you create this document that is time-stamped. It can be referenced in perpetuity. It has a stewardship in that you have an identified author that could potentially validate this. It's meant to represent a whole set of concepts specific to a setting, and it's meant to be human readable, either in XML or in a rendered format. There are 3 levels of CDA, level 1 being the most basic, where really you just have a CDA header and a body, and you can put anything really in it. It could be a PDF, it could be an image. There's level 2 CDA, which increases the degree of interoperability, where you have a body with a narrative block, and each of the sections is identified with a code. And then you have a level 3 CDA that has a header and a body with a narrative block and entries, which I'll show you. And then each of those entries should be fully encoded using the reference information model with reference terminologies or vocabulary such as LOINC, SNOMED, etc. And so this is what Meaningful Use had cited to try and get people to use this. So, like I said, this is the grand scheme of CDA in XML, where different things are tagged. And so why did this come about? There was the general need to develop clinical document architecture as a mechanism for exchanging information. And in a parallel effort in Massachusetts, they developed something called a continuity of care record, which is also XML-based. And they identified certain important information relating to individual from problems and medications. This was then used so it could be interoperable through exchanged in a region. And then over time, this was actually harmonized with the modeling of clinical document architecture to create the continuity of care document, which has required sections on allergies, medications, problems, procedures, and additional optional section. It's very important that health information exchanges, this is the primary currency of them currently, and there's a lot of potential value here. And like I had mentioned, we talked about you have the document, and then you have the body with a header that's conserved among different documents. It has a body which different sections and entries. So when you look at the document itself, you can see how the tags sort of identify the different groups. And each section has a narrative block, and they may have coded entries. So if these entries are coded, then getting to your point earlier, that can make them machine processable. And so some people refer to CDA as an on-ramp to interoperability because it allows the flexibility. You could have a block of text that people could later parse for natural language processing, or you could also define some structured elements that you could then capture with coding. There are other document types that have been created, including something through the Health Story project, where they created a consultation note, a H&P, a discharge summary, operative note, etc. But they ran into, and within those groups, we were able to conserve a lot of the sections. So by using templates, you could reuse things from the continuity of care document, as well as in the discharge summary. And you could, and so you didn't have to recreate the wheel. You could follow the same rules. But it became complicated. And what they found is over time, all these different groups have different standards for implementation, and it became a bit unwieldy. In fact, the HITSB C32, which is one of the first continuity of care documents mentioned in meaningful use, it was pretty simple. I think it was only 8 pages, but it referenced all these other standards, which referenced other standards. And by the time you got to the end, it became a bit unwieldy for people to know, how to manage that, and if they needed something reconciled, to what organization to go to. So then came the concept of consolidated clinical document architecture. So unfortunately, they didn't have the foresight to know that a continuity of care document has the same first 3 letters as consolidated CDA. And this has led to an unbelievable amount of confusion. So it was sort of a poor choice. But moving on, there's a consolidated CDA, which includes most of those document types, except for the unstructured document. Sorry, this is farther back than I realized. It includes all these types, as well as a continuity of care document. And now there have been additions to it for longitudinal care and other transitions of care. And the same sort of thing, you can take the XML and you can put it into a style sheet where you can render it in a browser, even though this one doesn't look very fancy. It's then machine readable or human readable. Now, one of the benefits, did I skip one? One of the benefits to having this being a level 3 CDA is that you can have your clinical information system like Epic receive a CCD, and once it gets that information in XML, it can parse it, and then it can present it to the clinician saying, hey, this information we just received says that they also have a shellfish allergy. Would you like to add that to the list, or our EHR here? And similarly, you can do the same for problems or meds or other examples. So even though it seems like a lot of work to have that infrastructure, regardless of where that document came from, clinical information systems are now poised to assimilate more and more of that information. But the other thing I wanted to touch on a little bit is leveraging that infrastructure that we have. In short, we have different terms which we map to similar concepts. And sometimes they even have clinical, these interface terminologies that you have misspellings or archaic terms that can still map to currently used terms. But what you can then do is leverage your subset of terms that were captured clinically and find out how many times did you get that within your EHR. So, for example, somebody may have a question saying, I want to know if an environmental exposure is related to different congenital anomalies of the lung based on what you capture in your EHR. And you look at that high-level concept and use one of the groupers, if you will, to decide which of these terms that you've captured in EHR to include. And to me, that actually becomes very valuable to then say, how can we leverage these ontologies and hierarchies based on clinically captured terms that some user entered, and now we're able to transform it into making sure that we've captured all these different groups or lists in a more efficient manner. And that example I just had was for congenital anomalies of the lung. We even did a project at our center trying to figure out all the potential diagnoses that related to DVTs or venous thromboembolism And so you're saying, well, we have to figure out when these events are occurring in a hospital. How do we find, what diagnosis list do we start with? And so you can take these high-level concepts and look for all their child concepts in your interface terminology, and now you have something to leverage. So that's most of what I wanted to cover. I'm ready for any questions, and thank you for your attention. Yes.
A quick comment that points out why when an administrator comes and says, well, how many asthma patients did we see? Why you say, well, I can't really answer that question.
Right.
So thank you for your insight.
No, sure. Thank you. All right.
Did you have a question, Pete?
Well, just that was a great overview of a very complicated subject. For the terminology like snowman, where you have pre-coordinated or post-coordinated, where are the tools to help? So if you've chosen a post-coordinated code to say, oh, you know what, there's already a pre-coordinated code that gets this concept.
So it is very complicated. Oh, sorry. It's a good point. It is very complicated, and Charlie and I talk about this every once in a while. Things aren't well designed and well modeled for post-coordinated concepts. It becomes much more difficult. But one advantage to using things like these ontologies is that you can still get a very granular term. So basically, you have people document as granularly as they can, and then you don't lose that term. It just maps to the higher level concept, and you can capture it. But it is true to deal with post-coordinated concepts is tough because you're then looking at multiple data fields. So it's an important issue to solve. But for now, in most of the data collection I've seen, you usually have a single pre-coordinated concept whenever possible.